Hey everyone. Am I on? I'm on. Okay, so the last time we talked, we went a little bit over my favorite DNA article, and I just wanted to read that a little bit more because, I think the graphics are great, that most of the information is still good. I learned a lot from it. I think the information is very straightforward. Easier to understand than other articles. Oh, Danger Zone! To die for! Aww. Welcome! It's so good to see you. So I'm glad that you like the art. You think it's the best article, Danger Zone. I think it's really good too. The graphics are so good. We'll have to go play with that high sensitivity, low sensitivity graph that they have. Aww. Well, enjoy your lunch, Danger Zone. Yes, to die for. I found you in the comments, so I was able to make you a mod. Danger Zone, I love all those hearts and diamonds. They're so pretty. Oh. Okay. All right. Make P, welcome. Okay, to die for. Welcome, everybody. I know that some of you said that the notifications don't always work. So I don't know what that's all about, but I just shared this as a post. So hopefully the notification will go out that I'm actually live, and then the notification will go out because I posted it. Oh, it's so good to see you guys. So if you guys remember last time, we went over this article called DNA Mixtures, a Forensic Science Explainer. What are DNA mixtures and why are they sometimes so difficult to interpret? And like I was saying last time, this article is dated April 3rd, 2019. So it does have a little bit of age to it, but a lot of the information in here is still very good. And actually, sometimes it can be better than other articles, in my opinion, that I've read. However, there was a point in here that I realized was a little bit of old info, and I was able to show another article where that info was actually updated. So as long as you know what info in there is actually outdated, you can still use the article. You just have to make sure that you reference this part is a little bit outdated, but here's the newer information, but then you can still share it. So, and this is one of my favorite quotes. Oh, really, Megp? Megp says, I watched a very good 2020 called Code Breakers about cold case DNA. That sounds awesome. Big P, let me see if I can find you, because then you can just put the link right in the chat. I'm sure you've commented before, because that sounds absolutely amazing. That sounds like a really good documentary, because like it really is, it's code. It certainly is code. Okay, I don't know why. Oh, Momo's thinking, welcome. Make P, if you comment below, I can make you a mod real quick, and then you can add whatever links you want in here. Hey, Too Fast for Fleas, welcome, best name. All right, so I was just about to say, let me see if I can blow this up. So one of my favorite articles, and this quote says, with old school DNA, the results tend to be clear-cut. Either a suspect's DNA profile is found in the evidence or it isn't. And non-experts can readily understand what that means. With DNA mixtures and trace DNA, the results can be ambiguous and difficult to understand, sometimes even for the experts. What does it say? With old school DNA, the results can be clear-cut. You know what? There was another, I don't know if it's this article that has, there's another quote that I liked. Okay. Oh yeah, and you remember this graph where there's low sensitivity, high sensitivity, and then it's an interactive graph. So when you pull it to the left, you can see all the high sensitivity where more of those DNA samples are shown. And then when you pull it to the right, it's low sensitivity and you don't see as much as the DNA samples. And this space right here, which looks like a kitchen or like a break room, is supposed to be representative of a crime scene. Like, what better way an article can be fun is if you can like play with it. Let's just all the colors go back and forth. I think it's just a very good demonstrative, like one of the better ones that I've seen in articles. Okay, so this isn't, there's another cool, gosh, I should remember which article it was, but it's that famous quote that I say almost all the time. Oh, Sharon, welcome. It's that famous quote, oh, your DNA was found at a crime scene, so that means you probably did it. I got that from an article. And it's such an accurate representation of, you know, the 1990s style education, DNA education. But, you know, people need to, you know, hopefully people are interested in learning a little bit more and getting an education past the 1990s when it comes to DNA. You know, there's been a lot that has happened since the 1990s, but it's like, for whatever reason, a lot of the public and some of these jury members, they've been stuck in the 90s. Like, I'm so happy there's curious minds out there, like all of you here in chat and everybody on Replay Crew, you know, that you're interested and open for the science behind DNA that could change a little bit. You know, that you're open to that concept. I don't know, people are just like, well, if there's DNA at the scene, that means they did it, and then they close the door on it. I don't know of any other science that just is stagnant like that. Science is always like either slowly or rapidly changing depending on what industry it is. Oh, it's so good to see you all. Oh, Sharon asked, she asked Made P, is that the one that Ortham solved? Oh, and Makepeace says yes. Makepeace says, so the very good 2020, I guess, documentary that she watched called Code Breakers about cold case DNA, Ortho was actually the one who broke the case. That's amazing. The Makepeace says the middlemans are in it. One guy testified for Bika's case. Really? Awesome. That is very cool information. I don't know. Let's see. Yeah, that would be great if you could find us that link when you have time, Miss P or Meg P. Oh yeah, she says that the guy who testified was for the state. All right. Last time we picked off here, we were comparing these DNA profiles, where the example of the article up here says, when the evidence contains plenty of DNA, these peaks are easy to read. And these peaks are called alleles, and they're in the shape of a triangle, and they're all different heights. I'll just read this real quick to give us a refresher of what this article is. It says, why are complex DNA mixtures difficult to interpret? To answer this question, it helps to know a bit about DNA profiles. When generating a DNA profile, forensic scientists don't analyze the genetic sequence. Instead, they look at roughly 40 short segments of DNA that vary from person to person. Those different variations are called alleles, these are alleles, these triangles. Or they're representative of an allele. And the key to knowing a person's DNA profile is which alleles they have. To find out, forensic scientists need enough genetic material to analyze. So they make millions of copies of the alleles. After amplifying the DNA in this way, scientists run the alleles through an instrument that sorts them the way a coin counter sorts coins. Instead of ending up in coin slots, the alleles end up as peaks on a chart. Those positions of the peaks indicate which alleles are present. That is, they determine a person's DNA profile. When evidence contains plenty of DNA, those peaks are often easy to read. For example, imagine a case in which a killer cuts himself on the knife he used as a weapon, leaving drops of blood at the scene. Analysts have created a DNA profile from those drops. In addition, the police have arrested a suspect, collected the suspect's DNA, and generated a profile. And here are what the two profiles may look like. Okay, I blew it up. All right, can you guys see that up top? It says this is the evidence profile that they found at the scene. They looked at some of the repeating sequences of the DNA, and they put the alleles, I guess, into like a coin sorting. And these are representative of that DNA profile. And this reference profile is also known as the suspect profile. And you can see these are very close, but they are slightly different. I can see this second pair here for the evidence profile. This peak is higher than this peak on the right. And down here on the suspect profile, these peaks are pretty even. Even though it's like, oh, and the same thing looks like it's going on over here with the next pair. These peaks are uneven and these peaks are even. So there are some similarities and there are differences, but these are representative of their DNA profiles. Alleles are said to match when their peaks fall at the same height, right to left, position to the chart. look at varying profiles from unrelated people, it wouldn't be unusual to find that they have a few matching alleles. Just as it wouldn't be unusual to match 1 or 2 numbers in the lottery. It would be incredibly unlikely for all the alleles to match. So, do the 2 profiles in the graph above match? They do. And the DNA analyst would use well-understood statistics to calculate the strength of that match. This analysis does not require much interpretation. In contrast, evidence that contains trace amounts of DNA or DNA mixture can require a lot of interpretation. So I also do want to mention that, yes, they're talking about identity here. They didn't include the how and the when. And I also, before I move on, I want to show you oh, you know what? It's over here. It is the human factors in the systems approach. It is, did I have it up? It's the newest. It was that that big article that Bika Barlow had referenced, and we had read it. It was like 436 pages. I could have sworn I had that up. I don't. I gotta find it. It's from NIST, the National Institute of Standards and Technology. It's the Human Factors and a Systems Approach. It was published in May of 2024. Yeah, here it is. Okay. It's the how and when questions. So it's at 172. Well, what I'm looking for, I had already put it on the thumbnail of this live, because it says here, Sheepbait, welcome. Is Echoes of Clarity in here too? Welcome, Echoes of Clarity. I was listening to some of your live earlier today. Actually, I listened to it in the background for most of the afternoon. Yvonne Poole, welcome. Good to see you. Or Sharon says Ortham is about 45 minutes from where I live. Oh, wow. Okay. So this is the article that Bika Barlow references, and coincidentally enough, we read this before that her motion came out, her scathing DNA motion. And so the one thing where I think my favorite article goes wrong, they're still assuming that identity is associated with guilt. But now science is realizing that identity is a different question than the mechanism of transfer and the how and the when, the activity level questions. And so before I move on, I just want to make that clear that is some of the old information that article has. This is the latest and greatest that has come out in the scientific community. It says here, the importance of case assessment information. Determining if DNA testing can help answer the questions posed is a critical decision point. An investigation may start with the question of whose DNA was left at the scene. But as more information is obtained, the question may become how was the DNA left at the scene. In other instances, the source of the DNA or parties involved may not be in question. And DNA testing to help address source level questions may not be of value. Investigators may be interested in other questions. For example, what type of biological material is present or absent? Is it male or female DNA? Is the DNA profile associated with any profiles in a DNA database? Could the DNA have originated from the person of interest? Are there possible alternative explanations for the results? How and when was the DNA deposited? How and when was the DNA deposited? That's the mechanism of transfer. And this current time in science, there is no technology to assist experts in answering that question. And lab analysts are actually limited to identity. They are not trained to answer any questions of how DNA was transferred. And when it comes to when DNA was transferred, there really isn't any science or standards in place for that either. So it says here, the analyst can help address, but should never directly answer questions whether a given individual is the source of the biological material or not. What can or should be said about how and when was deposited is the topic of ongoing scientific and legal discussion. So that is still being worked out within our science community and our legal community. And so I have read, it was in 2024, some of the newest research that I read then. It's been a while since I went and I looked through all the scholarly journals. They were just starting some experiments to test how long or to determine when DNA was deposited. And each one that I read had like inconclusive results. You know, they had some results, but they weren't able to compare it to anything. So they really weren't sure, you know, how to validate the information they were getting. It was more just like data collection. And anytime, you know, a science or a lab or the science community, they want to start researching in other areas and develop empirical data, you need data in general. Even if the data doesn't work out, you need the database to be able to say, okay, this is what worked, this is what didn't, this is what worked some of the time, that's what worked a lot of the time, or that one was just never going to happen. So that you have some, like, a foundation of where you want to go, and so that you can have a scientific approach to approach these types of questions, like the how and the when. So I do think that is being studied now, but there hasn't been any conclusions on how to use the scientific method to approach or even answer these types of questions of the how and the when. And it's so sad that, you know, we're this past 1990s, and then we're just getting around to, oh, we might not actually know how or when transfer DNA arrives at a scene. And it's like, well, you know, I think trace and transfer DNA is some of the, you know, the highest reasons of wrongful conviction. And it is because of these questions that may not have been considered before, but, you know, thankfully they are now. Yes. So this is critical. Oh, this should be good before I go back to the article. It says here, questions about how or when the DNA was deposited. Pre-trial meetings provide a crucial opportunity for DNA analysts to reiterate that DNA comparisons in isolation do not answer questions about how or when the DNA was deposited. Analysts can explain that the DNA comparisons do not address the possibility of any suggested transfer scenario intended to explain the presence or absence of the person's of interest DNA. The experts should discuss the following considerations if the questions in the case have shifted from source to activity. It says if. Ann Taylor's going to get in there and or actually it's probably Bika. She's going to get in there and she's going to change and shift these questions from source to activity. I mean, she already has with her motion. So the experts should discuss the following considerations if the questions in the case have shifted to from source to activity. If neither party is contesting the source of the DNA, the statistical value should not be a focus of the presentation. That's interesting. I want to think about that one a little bit more. If testimony is still offered, the expert should communicate the value of the DNA comparison, whether it's the likelihood ratio or the random match probability. They should communicate that the value of the DNA comparison does not apply to questions regarding disputed activities, and the scientist must explain that it is not possible to say whether the transfer was more likely direct or indirect. Let me read that again. The experts should discuss the following. The scientist must explain it is not possible to say whether the transfer was more likely direct or indirect. This is the latest from the scientific community. It came out in May 2024. It took 4 years to put this together. There is a lot of information, and the systems approach that they were using, like standard operating procedures of how different labs, different police departments are run. And they've come to this conclusion that scientists must explain that it's not possible to say whether transfer was more likely direct or indirect. And that's exactly what Riley Nolan did in that transcript. And that's exactly why Bika Barlow is calling her out on it. What page is this? We want to remember 169, because I definitely want to come back here. But we've got to make that clear. So when we are reading this older article, you can keep that in mind that this article is only talking about identity. It's not talking about the how and the why. And just to give you a refresher, see, this is May 2024. This article is called Forensic DNA Interpretation and Human Factors Improving Practice Through Systems Approach. That's the whole system. That's from beginning to end, where the DNA, come from the choosing of the locations to swab, to test for DNA. That's part of the process. That's where it starts, because there's just strategic ways that analysts and techs, they want to be able to choose with the scientific method which locations are the best for swabbing. And sometimes law enforcement doesn't really know that. There's still there's studies out there. One was from the EWG, the working group, where they have actually put standards together on the best ways to approach and to choose locations of where to swab. And of course, that doesn't always trickle down to law enforcement when they want to look at certain locations to swab, okay? And then it goes all the way into the lab. It goes into the statistical software. And then, the operating procedures of the lab. And it all has to do with how they catch errors, what they do, and what are their standards? How far are they willing to go down to that analytical threshold? Are they going to play it safe? Or are they going to run the risk of unreliable results by not having any standards? Are they going to do they keep their standards of practice updated? Do they follow any best practices? Are they part of any continuing education for the law enforcement and the lab personnel? Are they up to date on the latest science? Are they getting their credentialing, in a timely manner throughout actually creating and putting together the reports, through actually testifying, in a courtroom setting, all the way through the end user, and then, conveying that information to the fact finder and the jury. That whole process is a system. And this is exactly what this article is talking about, that now they want to focus on the systems approach, because this piecemeal thing that they were kind of doing before, as that can increase error. So it's not just, okay, we found this location at the scene, let's look at the biological material, let's see if it looks similar. Yes, we got a match, that's it. No, it's an entire system. And within this systems approach, there are a lot of other different underlying systems. And of course, you even have like work culture systems that can influence the results, depending on which lab or which law enforcement branch it is, because anytime you go to a workplace, there's always a personality or a work environment, that can affect, whatever the output is and whatever work is actually being done. So this is a report of the expert working group on human factors in forensic DNA interpretation. So forensic DNA interpretation includes all of that, all of the systems. And it's that way for a reason, to keep things documented, clearly documented, to be able to reference, if there was an error that occurred, and they have systems in place where they can quickly correct that so it doesn't keep, rippling effect out of control. And also, these other bodies down here were involved in it: the Human Factors in Forensic DNA Interpretation, NIST, National Institute of Standards and Technology, U.S. Department of Commerce, and the National Institute of Justice. So these are some big names in the scientific community, and these are just some of the big names that are actually on the document. There was probably other entities that were involved in this huge project that they did. And look, up here it says NIST Interagency Report. This is a scientific report. And so this is a little bit more comprehensive than the article here that I'll go back to. Whoop, that's not the... Oh, here it is. Yes. So what we were just reading there is more comprehensive. It was more of a to revamp the industry, to create better standards of practice, to create more stringent standard operating procedures, to implement more of the systems approach, the whole system, the entire life cycle of that one forensic piece of evidence, and how the systems work to filter that through to the end user, which that's definitely more comprehensive than this article that we're reading here, which is just trying to give you an explainer, to give you a quick rundown of the different concepts that go along with this. Let me come back and say hello. Let's see here. Momo's Thinking asks, how many cases will be overturned? Well, I don't know, was first. Second, the most concerning thing that I hear about wrongful convictions is there are a lot that we don't even know about. The ones that we do know about, that information was probably very difficult to get. And I don't really know how the legal system works. Like, if there is something like that, say that there was some sort of error that needs to be corrected in the legal system, I don't know if it's like, if there's a certain date from now on, this is how we're going to treat that in the court system, and this is how we're going to rule. So, like, if your case was before that date, you may or may not get a reconsideration. I don't know if that's the case. It must it must relate on several different possibilities. And hopefully there is just light. There's light shed on these wrongful convictions, that type of information does become visible, does come out in truth. But a lot of times it's really hard to know something we don't know. And there's a lot of times if somebody's wrongfully convicted, that information just isn't there to be able to show that, which is the saddest thing. To die for. Great question, Mamo's thinking. But yes. So I did need to go on that little caveat so that you can see the difference between what we're looking at here. That the big one from NIST, that is a huge scientific report. It's a consensus, the latest and greatest from the scientific community. And this is a fun article that helps explain the different concepts. So when they are talking about identity here and saying, well, your DNA was found at a crime scene, so you probably did it, that's a little bit of outdated information now, just so we have that. So now I'm going to move on. So it does say these profiles up here, they do consider them a match. They are very close. So there's that. And then it says the DNA analyst would use well understood statistics to calculate the strength of that match. This analysis does not require much interpretation. In contrast, evidence that contains trace amounts of DNA or DNA mixture can require a lot of interpretation. Oh, that's right. They said this was a blood sample. And so blood is more indicative of somebody having been present because they spilt. But I don't know if that's going to change in the future either. I'm sure there's more that we can learn about the how and the when of blood. What is it? Blood expulsion? Losing blood at a crime scene. There's a little bit more empirical evidence that, science and even juries can understand that most likely if there was blood spilt at a crime, that person was most likely present. But I wonder if that'll change. But yeah, so this is blood droplets. So that's much different. And that's probably why this is a little bit clearer to see this match. Oh, welcome, Larissa Harris. Larissa Harris asks, can I ask you a question if you know? I saw you on Miss Past chat. Why do some states not allow touch DNA in court? I believe there are some that don't, if I'm correct. I think you are correct. I know that in Maryland and DC, there's regulation, and Stephen Mercer helped put the laws in place to regulate and to have more laws that protect the public from using the types. Well, that's for the IgG, but for me, IgG is very related to touch and mixtures. And so when there are laws in place to help regulate the IgG, that also, I do believe, cuts down on the use of the touch transfer DNA. But in specific states, which ones use it and which ones don't, I'm not sure. I mean, a lot of states, or all states, have their own laws, and in each state it's different. And I know that the attorneys have to pass their own state bar. And so you'll hear a lot of times where attorneys are like, well, I don't practice in that state, but, if I was going to generalize, this is, and from my experience, this is what would likely be a possible answer. So to that question, I don't have a list. I can tell you that I've heard Lana say I don't want to put words in her mouth, but in Indiana, they didn't want to use IgG or touch transfer DNA. So I don't know. I hope maybe there's information out there about which states do. I don't know if you can do a quick search, but that is a very good question. I do know in Maryland and DC, there are some laws against that. And I do know in Maryland in particular, in regards to IgG, there are at least 13 bodies that have eyes on the use, how it's used. They keep an eye on how it's recorded of how IgG is used throughout the investigation, and they keep that on record. And they do yearly and annual reviews of it, so they can keep track of it, especially for like appeal situations. Okay, so let's go back here. In contrast, evidence that contains trace amounts of DNA and DNA mixture can require a lot of interpretation. For instance, imagine that a killer in the case above didn't cut himself and leave droplets of blood at the scene. However, investigators recovered the knife and swabbed the handle to find touch. They even used touch. That's not appropriate. It should be transferred DNA, I suppose. Hoping to find transfer DNA. The profiles might look like this. So the evidence profile here. Wow. So these peaks are smaller and there's more of them. I see an A and a B. And then the reference profile looks like the same from above. It must be the same reference from the what they got from the suspects. So it says, in this case, we can assume from the number of peaks that the evidence contains DNA from more than one person. Oh, that must be why there's a lot more of these peaks. So that would be a mixture. In this case, we can assume the number of peaks that the evidence contains DNA from more than one person. The peaks are small because the amount of DNA is low. Interpreting this profile involves at least two uncertainties. Okay, this is where it gets awesome because it's got my favorite alphabet soup example that I'm always trying to explain. Yeah, we love those types of questions around here, Larissa Harris. Thank you for being here. Caroline. Oh, Caroline Prestige, welcome. Awesome. Yeah, okay. I missed Preston last time, so if Preston's in here, everybody give him a hello. Okay, so Sheepbake looked it up. Thank you. She said, I can't find anything past 2021 regarding the touch transfer DNA by each state. Each state can make their own laws regarding it, though. Yeah, it's kind of tricky to figure that out, but I do know that in some states they don't want to use it. But I that's only what I've heard. I don't know specifically. Here we go. Uncertainty number one. When is a peak a peak? When the amount of DNA is low, the peaks can be very small. Some peaks can be so small that they disappear entirely. They drop out of the profile. Also, small blips in the data can be mistaken as real peaks. They drop in to a profile. Many of these effects are random, and they can make it difficult to interpret the evidence. Uncertainty number two. Whose peak is it anyway? When analyzing a DNA mixture, the alleles from the contributors show up on the same chart. This can make it difficult to tease apart the DNA profiles of the individual contributors. To understand why this makes things complicated, recall that after amplifying the DNA, the forensic scientist has a test tube of millions of copies of alleles in solution. Think of that test tube as a bowl of alphabet soup. In this bowl of soup, each letter represents a different type of allele. Our suspect is named John Q. Suspect. So these types of alleles will represent the John Q. Suspect profile. In this bowl of soup, each letter represents a different type of allele. Our suspect is named John Q. Suspect. We analyze the soup and find that all the letters in the suspect's name are present. Does that mean someone named John Q. Suspect contributed to the soup? Not necessarily. There could have been two contributors named Patrick Queen or Justin Orr. In that case, the soup would have all the letters needed to spell John Q. Suspect, even though no person with that name contributed to the soup. This is the same concept that Professor Jamieson, the Scottish professor, the Scottish forensic scientist, that I have to re-record that interview because I was having internet troubles and the sound wasn't very good. But he was saying the same thing because he was being interviewed and there was a pitcher of water there on the table with him and the interviewer. And he said, take this water pitcher, for instance, both of our DNAs on it. Say you are the DNA profile AB, I'm the DNA profile CD. So scientists will be able to look at that picture and they'll be able to see that you're AB, I'm DC, and that they're on there. But they're also going to pull out a DNA profile of BC. And as we can watch, we're looking at the interview, there's no one else there. So whoever is representative of that BC profile doesn't exist. They're not present. And so this is the same concept here. It says we analyze the soup and we find that the letters in the suspect's name are present. John Q. Suspect. Does that mean someone named John Q. Suspect contributed to the soup? No, not necessarily. There could have been two contributors named Patrick Queen or Justin Orr. In that case, the soup would have all the letters needed to spell John Q. Suspect, even though no person with that name contributed to the soup. What do you guys think of that? Chic Bake says it's Montana and Maryland were the first two states. Thank you for that, Chic Bake. Yes, what a great question, Larissa. Thank you for that. Yeah, you bring up a very good point here. It's concerning that a lot of people think it's error-proof. Very good point. Yvonne says, even if everybody stated about the DNA and IgG is true, that is not probable cause for arrest on familial DNA match. You must match the suspect DNA to the sheath STR profile to arrest. Yvonne further says they arrested on his dad's DNA possible match, not from BK's DNA from the trash. They only had probable cause for a warrant for BK's DNA, not to arrest. Didn't match buccal swab till after the arrest. Yeah, I think that's how it went. All right. So here we go. Look. So here's our soup that says John Q. Suspect, and we're not certain if he's actually part of it, of the DNA mix. And so down here, they have pulled out Patrick Queen and Justin Orr. However, all the letters in here to spell John Q. Suspect are in here, but John Q. Suspect wasn't necessarily present. This illustrates an important point about DNA mixtures. Just because a person's alleles appear in a mixture does not mean that person contributed to it. The alleles may have come from a combination of other people who between them have all the allele types in the suspect profile. I love this example because I think it's the easiest, I think, to grasp. And it's also fun. Like we're looking at alphabet soup. This is great. And then, this article has some humor. It says, would you like more soup? Recall that the amount of DNA is very small. The peaks on the chart will be small, and random effects like drop in and drop out become important. To continue the soup analogy, a letter can get so small that it disappears into the soup entirely. That would be drop out. Other times, a speck of pasta might be mistaken for a real letter. That would be drop in. Here are some ways this might affect the situation for John Q. Suspect. If the letter Q dropped out, we'd be left with John Suspect. This evidence would be less powerful because there may be many people with that name. The letter J dropped out. We'd be left with on Q Suspect. This evidence can still be quite powerful because the relatively low people have a middle name beginning with the letter Q. That letter really narrows down the search. What if the letter Q dropped in? In that case, some innocent but unlucky person named John Q. Suspect might fall under intense suspicion. Does that sound like anything that we've heard of? Let me read that again. What if the letter Q dropped in? In that case, some innocent but unlucky person named John Q. Suspect might fall under intense suspicion. Oh, that gives me chills. Because of these uncertainties, it can be difficult to know whether a suspect might have contributed to a mixture instead of a simple yes or no answer. The answer is often expressed in terms of probabilities. What is probabilistic genotyping software and how does it help? Scientists have developed computer programs to help interpret complex mixtures. Probabilistic genotyping software, PGS, uses statistical and biological models to calculate possibilities. For instance, the software is designed to account for drop in and drop out and other effects by using mathematics to approximate what happens in a real mixture. PGS also considers the fact that alleles are more common in the population than others, just as the letter J is more common in people's names than the letter Q. After computing these possibilities, the software produces a number called a likelihood ratio. That number is the software's estimate of how much more or less likely it is to see that mixture That number is the software's estimate of how much more or less likely it is to see that mixture if the suspect did contribute to it than if the suspect didn't. The jury may even take that number into account along with the other evidence when deciding guilt or innocence. In many cases, mixtures can be interpreted more reliably with PGS than without it. If the analyst understands the assumptions made by the software and the underlying mathematics, this can make PGS an extremely important tool and one that can help investigators solve many crimes that might otherwise go unsolved. However, the type of software used, how the software is configured, and which models the software runs can all affect the results. Oh, and I want to make another point here. The type of software, how the software is used, how the software is configured, and the models the software runs, that is all a part of the systems approach. That is all a part of that big NIST report from 2024. These types of factors, they want to be standardized and part of a system, sort of like a uniform system that is that you can measure that. You can measure that within a lab. You can see empirical results of like how that affects and how that works within their particular system. So those are all very important to understand. And I do think that that's why standard operating procedures are important for the defense to have. They need to have that evidence, or they need to have this information because it's part of the interpretation. You know, the interpretation is more than just looking at the biological material or looking at what the software spits out. It goes into a lot of the systems approach. How does the system formulate the answer to the question? How does it formulate the match? And that is one thing that we did learn from the motion in limine for Middleman, and I think there was another one where the state had in its possession the standard operating procedures from Ortham this entire time, and I think the defense got them in February 2025. That is significant because that could be considered the prosecution was withholding parts of the interpretation of the genetic material that they processed to arrest or to get probable cause for Brian Kobarger. That's completely unacceptable if you're keeping part of the interpretation away from the defense. So I just wanted to point that out, that these factors are part of the systems approach and they are very important and they should be very visible to the defense because they're part of the interpretation. So anyway, therefore, different labs might produce different results when interpreting the same evidence. Sometimes those differences can be large enough to call into question the reproducibility of the results. This highlights the fact that every scientific method has its limits, as some mixtures will be too complex to reliably interpret, even with PGS. Currently, there's no consensus on how to identify those limits. Currently, there's no consensus on how to identify those limits. However, in 2024 of May, they did adjust these limits, and they did. They have suggested a systems approach. So here's another piece of older information in here, and we are able to identify it because we have read that huge, beautiful NIST report about the systems approach. So there is now a consensus on how to identify limits and best practices. That's amazing to come back to my favorite article and be able to see when this article was written, where science and transfer and mixed DNA was, and then to sit here now with all of you and to know where it is currently now, because this article was written in 2019 and the NIST report, I guess we should call it a report, not article, was 2014. So there's been a while. Finally, with PGS interprets DNA, while PGS interprets DNA profiles, it does not address an important uncertainty associated with DNA mixtures and trace DNA. For example, it says DNA can be transferred from one person to another via a handshake. How confident can one be that the DNA is related to the crime? Well, PGS can tell you who, that's the identity question, that's what labs do, and lab analysts, the identity. While PGS can tell you who might have contributed to the DNA mixture, it can't tell you how or when it got there. Oh, so this article does have that information in it. They had this back in 2019. So if this article, this is also NIST, by the way. So this is, wow, I just put that together. So this is NIST from 2019, and we were reading the NIST report from 2024. So if NIST in 2019, when this was written, they knew then that labs and the PGS and lab analysts cannot, they might be able to tell you the who, but they can't tell you when or how the DNA got there. That's right here in 2019. Riley Nolan should know better. She should have been taught to stick with the identity questions, and yet she's inserting erroneous opinions into a death penalty case. That's scary. Okay. While PGS can tell you who might have contributed DNA to a mixture, it can't tell you how or when their DNA got there. If the evidence contains a lot of DNA, this might not be a problem. For instance, investigators at the scene of a home invasion and a homicide might find a broken window with blood on the glass. And in that case, they might reasonably conclude that the killer broke the window to enter and cut himself on the way in. In other words, they can associate the DNA with the blood at the crime scene. There's linking evidence. I would consider that linking evidence. You know, there's other factors or case information that could indicate that's a high likelihood of what happened. However, if the killer entered through an unlocked door, a swab of the doorknob might yield DNA from many innocent people who, in touching the doorknob, transferred their DNA to it, or somebody else's DNA. So, sure, we can touch things, but we might have someone else's DNA on our hands. So then when we're touching and we're doing things, we're transferring somebody else's DNA. In addition, DNA can be transferred multiple times. For example, if you shake a hand of a person who later touches the doorknob, your DNA can end up on the doorknob, even though you never touched it. Scientists call this secondary transfer. Situations like these show how it can sometimes be difficult to know if trace amounts of DNA are related to the crime. Scientists have conducted studies to better understand the factors that make DNA transfer more or less likely. They have found that some people tend to shed more DNA than others. And some objects and materials are particularly good vehicles for transferring DNA. Still, our understanding of how and how often DNA transfer happens is limited. When using high sensitivity methods, and we were able to play with that interactive graph at the top where we could pull that bar across the graph and it would show us low sensitivity and high sensitivity, and it would show us more DNA profiles under the high sensitivity methods. And so even when using our higher sensitivity, which is, our more powerful, I guess, lack for a better term, technology. So even when using our, lack of a better term, higher, more sensitive methods, however, forensic scientists are more likely to detect and get profiles from irrelevant DNA. That means that the risk of incorrectly associating a person with a crime has gone up in recent years. Cara Willis, a guest researcher at NIST and a former Director General of Forensic Science Ireland, says that mitigating that risk is especially important when dealing with samples containing very small amounts of DNA. One way to do that, she says, is to consider the totality of the evidence in a case rather than relying solely on an isolated fragment of DNA that might not be relevant. What does that sound like? Let me read that again. This is like the whole case. Okay. When using high sensitivity methods, however, forensic scientists are more likely to detect and get profiles from irrelevant DNA. That means that the risk of incorrectly associating a person with the crime has gone up in recent years. Cara Willis, a guest researcher of NIST and the former Director General of Forensic Science Ireland, says that mitigating that risk is especially important when dealing with samples containing very small amounts of DNA. One way to do that, she says, is to consider the totality of the evidence in the case rather than relying solely on an isolated fragment of DNA that might not be relevant. Which is this whole case. So, okay, they claim that they found the presence of Brian Koberger's DNA in an enclosed casing of brass, and it was lower than the amount was low that it's difficult to yield accurate results from. But as we know, they have all this other evidence. They have blood on the handrail. They have blood on the glove outside. They have the 8-hour gap. They have all of the friends that were there. They have the 2019 Sentra, or the 2011 to 13 Sentra, where they have that black Jeep diesel truck that leaves right after they say that car was speeding out of the neighborhood. We've got from the Linda Lane footage all of these people walking around. We have people walking to and from the home when police say the atrocity was happening. So there are all these other factors that are more indicative of better leads or information to follow than this one tiny isolated fragment encased inside of brass where nothing else relates to the case at all. And so Moscow PD and the state of Idaho, they're willing to bet justice for the 4 and an innocent man's life on an isolated fragment that may have nothing to do with the case. It doesn't match anything else. And then when you put the other factors, the information in the case that we have together, it actually does paint a story that should have been looked into. There's more substance on those factors. Snoopy Red, welcome. Good to see you. Because Payne had an eye level advantage. Diane, do you hear that? Only Payne saw it because of his eye level advantage. That's good. Oh, hey, look. Diane says the Snoopy risk. Don't steal my joke. You're so funny. You guys are so funny in here. All right, let's see what else you guys are saying. All right. Well, welcome, everybody here. All right, let's get back to it. Oh, there's a video here. I don't remember this. I've read this article, you don't know how many times, but for some reason I'm blinking on this. She was a guest researcher at the National Institute of Standards and Technology, NIST, and she discusses the risks associated with DNA transfer when the evidence in a criminal case contains very small amounts of DNA. These risks can be mitigated, she says, by considering the evidence in the larger context of the case. Oh, so her reasoning here is what MPD did not do. Let's see if we can play it. Let me know if you can hear it. This could be fun. Let's see. See how I make it full.
Human nature is such that we have a tendency to seek out technological solutions, and sometimes in our drive and our excitement.
Can you guys hear that? Oh, you heard it. Okay, good. I'll start it back over. So this is the former Forensic Director General of Forensic Science Ireland. She's going to talk about basically this.
Human nature is such that we have a tendency to seek out technological solutions, and sometimes in our drive and our excitement with the technological solution, we can sometimes lose the fundamental basis. About 15 years after the first use of DNA in forensic science, there was the realization that DNA could be transferred onto surfaces and detected. And that really spawned a whole industry and interest in seeing where we could detect DNA and how we could detect DNA, that may have lost sight of the fact that the DNA is not particular about where and when it transfers. And because the DNA is so powerful, this is in itself risk, because somebody can become so excited about probing the technology that they forget that actually maybe this sample wasn't relevant at all. So we need to be particularly careful. This information is so powerful that we need to be really confident and careful and sure that it's relevant to the event that we're investigating. And because of that, it's my contention that what we should be doing with forensic science is looking at a coherent narrative. It shouldn't be that one sample in isolation solves a case. And in my experience, you asked me earlier on about my experience in forensic science, and I had a lot of dealings with our police investigators and with our prosecutors indeed. And maybe it's the same everywhere, but no sound prosecution is based on one finding, no matter how fantastic that finding is. We certainly shouldn't stop using DNA, one of the most powerful tools available to us in crime investigation. Maybe we need to pay more attention on a case basis rather than a sample basis, and to think of the totality of the case and the context of the case, because we do need to mitigate these risks, but we couldn't possibly not get value from this amazing tool in crime investigation.
Now that I watched that, I do remember. That is awesome. All right, how do I? All right, thank you, Cara Willis. Should labs just stop analyzing mixtures altogether? No, these types of samples, though often challenging, can still provide very powerful and reliable evidence. If there's one thing you can take away from this explainer, it should be this: methods for interpreting DNA mixtures are not inherently reliable or unreliable. Mixtures exist on a spectrum, and the ability to reliably interpret a particular DNA mixture depends on the specifics of the case. I think that also goes for single source, what they say is single source DNA as well. So if there's one thing you take away from this explainer, it should be this: methods for interpreting DNA mixtures, or I think in low amounts as well, are not inherently reliable or unreliable. Mixtures exist on a spectrum, and the ability to reliably interpret a particular mixture depends on the specifics of the case. Now, I think in like a world that obviously we're not existing in right now, if this were a case in another jurisdiction with different actors, and everybody's different, change out all the people, change the state, I would hope that if a case like this happens, They do find, I guess, a very minute amount of DNA on the inside of a snap. They can put a pin in it, put a bookmark on there, but there's blood evidence to follow. There's, why was there 8 hours? Why did it take 4 hours for a lead investigator to actually be chosen and show up? The case, the case specific facts are just not there for this tiny, minute transfer trace DNA that is on the knife sheet. I don't know how to explain it. It's just like, I don't know, if you're going to try to do reasoning and logic and to follow your lab or your police precinct's protocols, when there's blood spilled, I would think you want to take off running with that. But I don't know why that didn't happen in this case. It's very frustrating now that we're all learning about what it is they actually found and how it doesn't have anything to do with anything else, which means it's highly likely it's irrelevant to this case. The key is to ask the right questions. How complex is the mixture in terms of number of contributors and the amount of DNA from each? How confident can we be that the DNA is relevant to the case? What other types of evidence exist to corroborate the DNA evidence? Perhaps more than any time since forensic DNA methods were invented 35 years ago, this type of critical thinking is needed. It's also important to understand that all scientific methods have limits. How far can we push new methods when interpreting complex DNA mixtures? How can we establish consistent protocols for deciding when a mixture is too complex to interpret reliably? What additional training do forensic analysts need to use new methods appropriately? NIST has completed a study that evaluates these issues called DNA Mixture Interpretation and Scientific Foundation Review. And this study evaluates the science behind these methods and identifies areas for future research. Isn't that interesting? At the end of this article, NIST is proposing the questions. How can we establish consistent protocols to interpret reliably? What additional training is needed for forensic analysts to use new methods appropriately? And they did it. They published it in 2024, that huge report. That is so interesting that they're asking the questions now in 2019 when this was written. And then this was written in 2019, and they started that big report in 20. So I wonder how soon after they wrote this article that they actually started that big report. That's interesting. That is so cool. So this is my favorite article. I'm going to go back up to the top so you can look at the artwork. These are all alleles. That is so funny. Okay, look. So NIST is a .gov. So this is a good website to get information. Well, NIST is also one of the best. So here we go. We just read DNA Mixtures, a Forensic Science Explainer. What are DNA mixtures and why are they sometimes so difficult to interpret? And it has that fun interactive graph, and it has that great alphabet soup example. What do you guys think of that article? This is my favorite one by far. Anyone I've ever read, I'm just like, this one is it. Oh, Preston Benson, welcome. We said hi to you earlier because I had missed someone and I had said hello, and I thought, oh, well, hopefully I didn't miss Preston, and if We did miss Preston. Tell him we said hello when he gets here. So welcome. Yeah, so that's my favorite one. Now, isn't that cool? This is April 3rd of 2019, and they're asking the questions that they answer in this, what the report that Bika Barlow referenced. I find that to be amazing that there's that connection. And this is that forensic DNA interpretation and human factors, improving practice through a systems approach. And you know what? Maybe as a yes, as a follow-up, I want to watch with because I have better sound now. We're gonna follow up with that. Where did I put it? Okay, here it is.
It is a big.
Okay. Oh, so we are going to follow up.
DNA transfer is a big issue just now because.
All right, can you guys hear that? This is the article. This is the short interview that we watched. I don't know, was it a week ago now, maybe? But my sound wasn't so good. So what I'll do that's put the cherry on top of my favorite article and listen to Professor Jamieson, and then I'm going to cut this out, and I'll have it as a short video, and I'll upload it so that everybody can listen to this too. And I will also add this into the link. I'm going to play it. Let me know if you guys can't hear it, okay?
DNA transfer is a big issue just now because it used to be when DNA started, we had identifiable body fluids. The technique wasn't very sensitive, so it was blood, semen, saliva, that type of thing. So you could see what you were testing. Now we've got weapons, drug bags, things like that, where we're just swabbing. It's trace evidence that's invisible. Some people call it touch DNA, and that's a misnomer because you don't need to touch something. Yeah. As I'm speaking just now, my DNA is going all over this table, so I hate to worry you. But, and so you took this glass and you put it there, right? And I touched that glass. I could pick your DNA up from that glass.
And then if you were to touch something else, you could spread my DNA.
Yes. So that's right. Well, remember that so going back to these swabs.
Yeah.
So you now do a swab, and you find 4 people's DNA on there. Now you can't say who touched it if they touched it at all. You can't say what order the DNA was deposited in. It could have been any one of them deposited the other 3. So that's the consequence of increasing the sensitivity of the DNA. DNA doesn't go about on its own, right? It's in cells, skin cells and so on. So you get about, let's say, between 5 and 10,000 cells on the head of a pin. We can produce a profile from about 10 of those.
Does it get to a point where it's too sensitive?
In my view, yes.
Because a lot of my time lines, right?
Sorry?
It blurs the lines.
Well, of course, because now when you've got the blood, semen, saliva, there's a connection with a fluid, which is normally a connection then to the crime. But there may be no connection to the crime with the techniques we're currently using.
So it's leading you down a path that is probably, or not probably, but maybe incorrect.
Well, as well as that, once you get to that level, you're also talking about mostly mixtures of DNA. For the reasons I've just said, you touch something, I touch something, now we've mixed our DNA, we move on to something else. I remember when I was the head of the police lab, 1990 something, right? And I warned about this, that this increasing sensitivity would lead to miscarriages of justice. And so what's happening is that the public remember new DNA, like when it came in, it was, the magic bullet. Oh, we've got his DNA, therefore it must be him. That's the criminal, right? But now, as I've explained, the DNA, your DNA gets places you've never been. That's now become a bit of a phrase everywhere, but I'm patenting it. But your DNA gets places you've never been. Because the example I gave is I shake your hand, go into my car, I've put your DNA in my car, you've never been there. So that creates a real problem. And so from the lawyer's point of view, for the prosecution, what they've got to do now is make a consistent story, not just from the DNA, which is why we went through a phase of some saying, oh, we'd never prosecute on DNA alone. Well, I've kind of seen them prosecuting on DNA alone. So, and that's dangerous. And when we come to mixtures, that introduces a whole new level of complexity. Because I mentioned, our DNA on the glass.
Yeah.
So let's say your DNA, or it's just labels I'm using here, your DNA is AB and mine's CD.
Okay.
So when we make a swab of that glass and look at it in the lab, we see ABCD. So yeah, you could be a contributor to that mixture, and so could I, right? But what about somebody else who has the genotype BC? If they're a suspect, they could also have contributed to that DNA, even though they actually didn't.
So is the DNA not specific to the person? Is it more like a...
Well, yes and no. But
Yeah.
remember, we're mixing people's DNA, and so you produce new profiles. And the example I've just given there, when we mix, excuse me, A, B, C, D, you can now get who could be a contributor. A, B, C, D, AC, BD, and BC. So from that simple mixture, you've now produced 6 suspect profiles.
Yeah.
Now that's just in one area and with a 2-person mixture, right? So imagine now, it's not just one area, it's not just the ABCD area, it's the other 16 or 20 odd. Once you do that, if you imagine you've created 6 possible genotypes at that one area, it would be 6 to the 16th or 20th. You go into the billions and trillions of false positives. In other words, profiles that could be considered as contributors, but they're not actual contributors. So you produce more false positives than you produce actual correct results.
And would the police kind of so they've got the DNA evidence, and then they would match that with who is the suspects?
Well, in fact, that's now what's happening, because let's say that there's software that they're using now called probabilistic genotyping software, and it uses statistics. And what it does is it looks at the profiles and it generates all the possible profiles the software thinks could be there.
Yeah.
And it gives each of them a weight, right? So it might say AB is number 1.
Yeah.
Right? But since BC is also a possible genotype, it will also give that a positive weight. In other words, if somebody's BC, it will produce a high number for them as well, even though they're not contributors. Okay. So the software produces a big list of these genotypes. And what I do is go through it and see where the suspect is. And I've got one just now where he's about 14th on the list.
Jesus. So you need to work your way down every single,
yeah, so it's a lot of work, but it's harder work if he goes to jail, and he shouldn't be.
Yeah, yeah.
So, my role is to point out the limits of the evidence, rather than follow the leader.
Is there a difficulty when it comes to the cooperation of the police department in terms of giving you everything?
Oh, yes. In Scotland...
Hit a nerve.
You hit a nerve on there. Scotland has the most restrictive disclosure regime in the world.
Right.
Okay, I do work in America. In fact, just now, I think I've probably got more cases in New York than anywhere else. Florida, Australia, New Zealand, and England and Wales, obviously, Ireland.
Yeah.
And the tradition and the correct tradition, the right way to do things, is that the lab should turn over their case files, because that logs everything that they've done, the tests they've done, the results they've done, and allows us to examine it.
Yeah.
In Scotland, they don't do that.
Right.
And we've had I mean, it's on our website. We've had correspondence with the Justice Minister, and everybody's just Teflon shoulders. Oh, it's nothing to do with us.
Right.
And it's the problem. Well, there's two problems. One, the Scottish Police Authority. They're the proximal problem, if you like. I mean, it's them that are saying, no, you're not getting this. But I think beyond that is the Justice Minister, who just needs to say to the Scottish Police Authority, just give them the results like every other country in the world, right? So, but nobody's listening. And when the lawyers, that's, well, maybe not for this case, because they don't want to challenge it. So it's very disappointing. I mean, the Herald did an editorial on this in 2011. That's how long it's been going on. We cannot properly analyse the evidence by simply visiting Gartcosh. Now, Gartcosh is where the police lab, or the main police lab is. Now, you have to remember here that we're paid by legal aid.
Yeah.
So the Scottish Government are paying, the taxpayer, are paying for the Scottish Police Authority to examine this evidence that's going to determine whether somebody goes to jail or not, right? So they've paid for that work. But now, when we ask to see it on behalf of the defendant, they say, no, you've got to come to us. So we can't copy it, even when we're there. And this only came about when Police Scotland came about, incidentally. It used to be the individual police forces were okay. So, but now I can't, and my colleagues can't discuss it because we can't see it. We can't put it in front of us and discuss it, right? So, and we're supposed to have this so-called peer review, where it's not just one scientist is looking at it, it's two scientists.
Is that to remove like bias or prejudice? Or...
Yeah, well, it's more expertise as well.
Yeah.
You know, I don't know everything. And so it's appalling and absurd that in 24, that we have the most restrictive disclosure rules for scientific evidence in the world, and yet nobody seems to care.
It's bizarre.
Awesome. I really like that interview. I know he might be a little difficult to understand. So what I'll do is I'll clip that little part out after the live, and then I'll add some fun, colorful subtitles to it. So that'll be fun. And I know one of the things that he talked about that I wanted to look up. Oh, let's see here. Well, let me go back to see what you guys are saying. Let's see. So Larissa Harris asks, I remember from the closed hearing, some scientists don't have their notes on methods used. They have to talk about their methods in trial, right? Not taking words as fact in a DP case. I do believe that you're correct, Larissa. The defense will ask the state's, well, I guess the state will ask the defense expert as well. They want to know. They want to know the techniques, and they want the jury to be able to know what techniques that they use, because you've got the two hypotheses for each case. There's the state's hypotheses, their story of what happened, and then there's the defense's hypotheses of their story of what happened. And so naturally, the state is going to want to ask particular questions so that the expert will answer. And so that the state does want to show the jury that what they did is correct, and they want to show them these are the methods we use, this is how we do it, this is how we did it, and our results are accurate. And they're going to say, well, since our results are accurate, then the defendant, most likely did this crime, so convict him. Whereas the defense is going to say, well, these are the methods that we used, or this is typically the scientific standard. How does this relate to what you did? What are your standards? And then a skilled defense attorney will be able to ask some more questions and get some more information out of there. So, yeah. And actually, in that closed hearing, I think I know what you're talking about. In a bunch of the hearings that we've watched, I think Anne in particular, I was like, well, do you need a refresher? Let me show you. Because she had documents, even documents of like emails or documents of different reports that they wrote. She'll give it to them so she can remind them of what they wrote or said. So yeah, they have to. And I think they are allowed to have some notes to like refresh their memory. But yeah, great question, Larissa. That's what I think. I might not be right. That's just what I'm thinking. So Sharon says, she says that he is definitely tied somehow. They have slipped too many times with his last name. Okay. Oh. Are you talking about Kopaka? Okay. Snoopy Red says, I don't believe that any DNA of his was on anything. I thought that for a very long time too. Snoopy Red says, the state won't fold. They're going all in, even though they're playing with a lot, with not even a pair. Yep, I would agree with that. To die for, Diane says, what comes out raises more questions. Larissa says, I think prosecutors want to try and not talk about databases against policy in trial. They have to own what was done. No lying to the jury. I completely agree. Yeah. Stupid Red says, false arrest, unlawful detainment, just to name a few crimes the state has committed. Well said. I would agree. Yvonne Poole says, I am 65 years old and I have loved crime shows and true crime all my life. I lived in Chicago when Richard Speck killed those nurses. I have never seen a case as crazy as this one. That is amazing. That is amazing. You probably have a lot of knowledge when it comes to true crime. You have a lot of experience too. That's incredible that you were there when Richard Speck was doing that. Yeah, I've loved true crime shows for a very long time too, Yvonne. And like there's a point where like, yeah, you're watching like everything that you can absorb. But then there was a point for me when I was like, wait a minute, I'm like watching these mainstream documentaries, and then at one point did we like break off into like YouTube land, and then we start questioning all of these documentaries that the mainstream media says. Like for instance, I can remember what is Maddie McCann? Is that her name? Where they were, oh gosh, what was it? It was one of those like first the like 2020 or one of those documentaries where they have like the intense music, and they had made a drawing of like this intruder that came in and like picked up Maddie, and he was like carrying her like a baby and walking away, and like they made like a big deal about how this is what must have happened. So let us illustrate the theory of what happened. And then I realized like if they try to sell something a little too hard, then I'm like questioning why are they giving me all that information? And then later, when I'm like revisiting all those true crime shows and documentaries that I watched and I loved, I really was getting into the information and like how they presented it and like how their reasoning for doing things. And then there became a point where then I went back after I started to question some of those things. And now that I'm like looking into those cases that were kind of high profile, and I'm finding that there's some issues with some of them. Like the Ramseys, the McCanns. I think that those were probably accidental deaths that were possibly covered up. But so that's why those are so wild. But there are some cases where, you had to go back and like relearn all about it just to kind of see what was going on. A little like this case, there's things in those that just don't quite add up. And of course, I don't know what happened in those cases. I'm just thinking that they were accidental deaths. But yeah, so that's really cool that, Yvonne, that you have been doing very similar things with the true crime. Yvonne says, show your work, basic math class rules. Prove you didn't cheat to get the answer, right? Larissa says, yeah, I find it strange and shady how the scientists answered questions in that hearing. Bothered me. Didn't expect science to answer questions like pain, right? That is also, that's concerning. I noticed that too. I don't think we should have been more confused. And so that's why I think those were important questions that Anne was asking. She was pulling out really good information from them. And because it was very strange, I think there is some guilty knowledge there of something. Otherwise, why wouldn't you just come out and just straightforward say, these are our standards, these are our protocols, this is how we approach this, and these are the conclusions that we came to. Very straightforward. And that's definitely not what we got. Yvonne, were you in the same location as John Wayne Gacy as well? Was he in Chicago too? I can't remember off the top of my head. Larissa says, that Angie Dodge case bothered me when the mother saw the interrogation tapes and she knew they have the wrong guy and police and prosecutors wouldn't budge a wrongful conviction. Oh, yes. That takes so much strength that the mother was able to say to law enforcement, people that think are infallible, that they're this authority figure that never gets anything wrong. And she's grieving and she's trying to go through this process. And she's like, no, guys, you have it wrong. And then didn't she start to help? Did she start investigating it? Or at some point there was another investigator on it. I think she got with them. And I think she did play a role in releasing him. And not only that, wasn't that Idaho? Idaho got IgG wrong. They got the DNA wrong, right? Like, it's just like, maybe Idaho, maybe you shouldn't use IgG. Like, you don't really use it that well. I don't think you quite understand what you're doing, Yvonne says, yes, my friends and family lived in Chicago when he was unaliving guys my age. Whoa. I live in Louisiana by then. Oh, okay. That is so cool. It's really cool that the people that you meet on here and you hear all about, their experiences and the different things that they learn and the very interesting and complex discussions that can be very rewarding and fun. So it's very cool, Yvonne, and thank you for sharing that with us. That is awesome. All right. So, I did say that other article, the other NIST article, is my favorite. But this one, this was also becoming one of my favorites too. But that could be just because it's the latest and greatest. So, what I wanted to look up, because who we just watched, the Scottish forensic investigator, he talked about limits. What are the limits of forensic DNA interpretation? And so I want to put in limitations and see what I can pull up here. Well, let's read a little bit about cognitive bias. I've always thought it meant, like somebody who just has their own opinion, that they are, they're just not going to change it. However, I was recently thinking about this week, where it's also called cognitive bias when you are working for a state lab and you're pressured to find a match or pressured to find an identification, that you're more likely to just identify something. And I'm wondering, because there's a little bit of a caveat there. There's a little bit of a difference. And so I'm wondering if that is cognitive bias, or if that's just institutional pressure, what that is. So let's see. How does the latest and greatest define cognitive bias? As long as a human analyzes and interprets forensic DNA evidence, the strengths and limitations of human cognition will be central to forensic casework. With human cognition, there is always a chance that expectations, task-irrelevant information, and pre-existing prejudices can affect decision-making. There are many forms of cognitive bias. A recent sweeping definition equates cognitive bias to effects by which an individual's pre-existing beliefs, expectations, motives, and situational context may influence their collection, perception, and interpretation of information, or their resulting judgments, decisions, or confidence. Cognitive bias can result from cognitive shortcuts, sometimes called heuristics, which help to make sense of the world quickly and efficiently. Biases do not necessarily produce error, but they can tilt judgment or measurements in one direction. Two types of cognitive bias are generally applicable to DNA analysis: confirmation bias and contextual bias. Confirmation bias is present when pre-existing beliefs and expectations lead individuals to give weight and attention to information that confirms their pre-existing beliefs, and less weight and attention to information that disconforms their beliefs. Contextual bias describes human judgment being influenced by irrelevant contextual information. These and other types of cognitive bias are discussed throughout the report. Okay. So it says criminal justice partners receiving DNA analysis opinions are also subject to cognitive bias. The expectations these groups of individuals have about a case or type of evidence may frame their perception of evidence. For instance, fact finders, for example, judges or jurors, may bring with them assumptions that DNA evidence is infallible. Oh, can we insert Hitler's name in here? You know, Hitler is going to read that scathing DNA motion. I'm going to be raving about that DNA motion Bika Barlow wrote for years, but she put it all in there. And I'm curious whether he strikes me. Now, he's led me astray before, but he strikes me as the kind of person who is thorough, who wants to be knowledgeable and intelligent, and efficient. And so I would think he might read a little bit, above and beyond what he's required to at his choice, not because the defense is asking them, but because of his own decisions. And that I hope he does read some of the things that she references. Because I do know that if he can just, I hope that if he could just see some of this information, that he's the type of person that would understand it and would remain more level-headed than he was behaving before. I'd like to give him that grace, because that's the initial impression I got. He's strict, efficient, smart, and in that he would be fair because of how close he is to, what law, that he wants to follow it, that he wants to be intelligent and smart about it, that he wants to be swift, and I'm hoping that all of those characteristics that I think that he's projecting, that he could take a look at some of this information and process it the way that I think that he processes information, and really make some insightful decisions or insightful comments. It'll be fascinating. I hope that he responds to this, to Bika Barlow's motion to eliminate. I would love to read what he thinks and how he's going to rule, and like how he came to that conclusion, regardless, regardless if I'm going to like his response or not. I am curious to see the cognitive steps that he took to get to these conclusions. Regardless if it's good or bad news, I think that'll be very interesting, no matter what happens here. Because Bika Barlow opened the floodgates. Now we're all going to watch where it goes. It's going to be great. So. What? Yvonne says there was a guy band, Archie, that was on America's Got Talent, that was in jail for 30 years in LA for wrongful conviction. Oh my gosh. A guy named Archie that was on America's Got Talent and was in jail for 30 years in LA for wrongful conviction. That is so sad. To die for? Diane says, to me, Larissa, saw it a year ago. I never forgot it. I shared it in Audrey's live a while ago. Great story. Hey! You're responding to Larissa here, right? What did she say? Oh! Larissa says, I think I saw a Dateline a while ago. Hasty wrongful convictions. They bring me to tears. I know, I can't go there either. Oh, here we go. So Larissa says, yeah, the mom of the victim, I was amazed by her strength and all she did to even help get the guy convicted out of prison. Forgot his name. Crazy, was it Chris? I can't remember his name. Crazy prosecutors still, though, they had right guy. Yeah. To die for, tunnel vision does happen a lot. Mark and Betty, welcome. So good to see you. Aw, you came in here. Okay, cool. All right, so oh, we were on page 162. I wanted to pick up. Right? Yes, here we go. Oh, this is all good. This is all great stuff right here. This appendix. Oh, this is fun. I don't know where we went though. Appendix 5.1. Example, caveats and limitations to include in a report. The following table consists of non-exhaustible list of example reporting caveats and limitations to include when communicating DNA results. Oh, this should be good. We were just talking about this, right? When the experts have to, they may or may not be able to look at their notes unless they are asked or offered, I believe. I don't think they could just take it up there. Here we go. Here, reason for the caveat or limitation 1. Communication through email correspondence. Example of reporting caveat or limitation. Unlike results and analysis conveyed in official reports, email communications convey this information have not been technically reviewed to assure precise language. Okay. Next reason. An alert on the importance of the case information. Example, since the evaluation presented in this report is dependent on the information provided and the propositions formed using this information, any change in the case information used to inform the proposition should be seen as a sufficient reason for new evaluation. If any of the information changes or if new relevant information is made, contact the forensic service provider to reevaluate the results as soon as possible. Interesting. So the email communication, the emails have not been technically reviewed to assure the price, so that they would need another eyes on it. They're not like official reports. However, if they get an alert of importance in the case, they might need to go back and reevaluate. Which I'm curious if Anne or if Bika Barlow is going to ask them, what are your protocols when you get an important alert about the case? And what do you do if that important alert, what is the criteria that you would have to reevaluate the results? Or what are the sufficient reasons you would need for a new evaluation? And I do believe in this case, there were several factors that occurred where an important alert about the case came in and they didn't perform any of their standards or processes when it comes to what kind of evaluation or standards or criteria do you need that would warrant a new evaluation or to reevaluate your results. Okay, so the next reason for caveat or limitation, underline the distinction between explanation of results and propositions. Example, the example of reporting that. The explanations of the DNA results provided aim to inform the investigation in absence of a person of interest. The list explanations offered may not be exhaustive or mutually exclusive and must not be replaced. The need to reconsider formal propositions once there is a person of interest. Any report or opinions offered once a person of interest is determined supersede these explanations. Wait a minute. We need to read that one more time. Because immediately what came to mind was that Ed Taylor was asking Payne when he was on the stand in that secret hearing that you had these blood DNA samples. Why didn't you test that? And Payne says, well, I guess he referring to Brian's or Q1.1 was already in CODIS and they didn't want to lose it. So he didn't want to put in any more DNA profiles. So let me read that again to see if this relates to that in any way. The explanations of the DNA results provided aim to inform the investigation in absence of a POI. The list of explanations offered may not be exhaustive or mutually exclusive and must not replace the need to consider formal propositions once there is a person of interest. Any reports or opinions offered once a person of interest is determined supersede these explanations. What does that mean? Underline the distinction between explanation of results and propositions. Larissa says, I saw a guy get out after 28 years. Robert Johnson, wrongful conviction last week. Thought you could be talking about him. He looked so happy and level-headed in the press. I don't think I survived. I know. Wow. I feel the same way, Larissa. Oh my gosh. Okay, next reason. A reason for a caveat or a limitation. Oh. And then this is how you would report when you're communicating about results. An alert about CODIS, investigative leads. An investigative lead generated as a result of a DNA database search was obtained between item 1 and person of interest. A reference from the person of interest must be submitted for direct comparison and statistical analysis. Using the DNA investigative lead alone has the potential to be misleading. It is important to evaluate the DNA lead in conjunction with the other available evidence. That reminds me. Nobody did a direct comparison between the SNPs. I mean, somebody said you might not have to do that, but why wouldn't? I don't know why you wouldn't. So the FBI didn't compare the SNP from the knife sheath to Brian's SNP. So how do we know? And Riley Nolan didn't compare the STR to the SNP that was created because she said her lab does not do that. There's a lot of debate on whether that can be done or not. There is no really direct comparison between STR and SNP. So there isn't a conversion that happens there. And with that conversion, well, not really a conversion, just a theoretical conversion, not an actual real one in practice. But so then they had an STR to a SNP. And to the SNP to, I guess, Brian's SNP, and then the STR to the STR. But how does that work? And nobody compared them for a direct comparison. None of those things were compared to each other, except for the STR and the STR. But you can't start at A and get to D if you don't know what's in between. And whatever happened with that SNP, if anything happened, that could throw off the entire family tree. And middlemen didn't, or the state didn't provide any of the standard of procedures for all through. So how do we know any of their interpretations are accurate? So then that would mean anything that happened between the STR obtained initially is inaccurate. It wouldn't lead back to the result. It wouldn't lead back to the original STR. So, I don't know. All right, the next reason for caveat or limitation. Alert on the biological sex information provided. Okay, and this is how communicating DNA results when reporting these reasons for caveat or limitation. Biological DNA-based sex information aims to inform the investigation and should not be interpreted to mean that an individual must also appear as a male or female based upon this indication alone. Furthermore, this information does not confirm that a specific cell type is present or imply how the DNA was deposited. Amylogenin shows only a peak X. As such, the profile appears to come from one individual and was reported as female. The investigative information reported by the forensic service provider regarding male or female contributors is based solely upon the assessment of the DNA types at locations on the X and Y chromosomes. One explanation for the reported results is the biological sex of the contributor is female and therefore consistent with what was reported. Another explanation could be that the contributor has had a deletion in amylogenin and appears to be female for this DNA location only due to analytical reasons. There may be other explanations. There are also situations where an individual's gender expression and sex chromosome types may not necessarily align. Therefore, this information should be viewed with caution and exceptions. Yeah, I think I got a question about that in the comments before, something similar about that. And that does get tricky because there's XXY, occasionally there can be an extra chromosome. Yeah, that can complicate things. Okay, the next reason, alert at the end user needs to request supplementary materials such as bench notes and electronic data if general description of how NOC is assigned. Oh, number of contributors. Okay. Right, bench notes. That's a buzzword. We heard that. Didn't somebody at the secret hearing was missing that? Weren't you saying that, Larissa? I seem to remember somebody was missing or didn't provide bench notes. Okay, this is how you would communicate this exception. The report does not contain all the documentation associated with the work performed or the content necessary to understand and evaluate all the work performed. There you go. This is how you properly respond to that. We have a situation in this case where bench notes were not provided. Ann Taylor was looking for them. She's asking for those through discovery. This is the appropriate response as an analyst you would give when somebody is saying, hey, we don't have the bench notes. And so then the analyst is alerted that somebody needs the supplemental materials and the bench notes. This is the appropriate response, which we certainly did not get. The report does not contain all the documentation associated with the work performed or the content necessary to understand and evaluate all the work performed. Independent analysis and interpretation of the data requires a review of the full case record. The true number of contributors of DNA to an item can never be known. The number of contributors for each DNA profile is assigned given the quantity and quality of the information detected as well as the relationship between the peaks detected. Additional information, such as item type and known contributors, may also aid in the assignment of the number of contributors. Yeah, so to me, if the supplemental material bench notes are missing, you're missing some of the interpretation. And if you're missing some of the interpretation, how can that ever be relied upon? In my opinion. All right, next one. General description of suitability determination. Decisions about the suitability for comparison to all or portion of the DNA profile are made prior to comparison to any reference profiles unless case circumstances support conditioning on a known contributor. Regarding an assignment of number of contributors above the forensic science service provider's validation range for interpretation will render the entire DNA profile not suitable for comparison. That reminds me of when Bill Thompson said that they had DNA profiles that weren't eligible for CODIS or eligible for further testing. Now I think we realize he was talking about unknown male B and unknown D. Unknown male D is the glove outside. Unknown male B is the blood on the handrail. Now, I was asked this question recently. What does it mean that these samples weren't eligible for CODIS or for further testing? I don't think that that means any sort of criteria. I know a lot of people want to put weight on the word of eligibility in this context about it meeting some sort of criteria, which means there's some sort of outcome, result, or action for those DNA profiles. But I think it's actually simpler than that, that those weren't eligible because law enforcement decided they were going to take the investigation in another direction. It was merely because of discretion. Now, when it comes to discretion and decision-making and systems comes into play when you deviate from your standard operating procedures and the policies that you have. And that's where that decision came from. Was it Payne or whoever decided they were going to go in the direction of this trace transfer DNA? They were going to use their discretion to say, this is going to be the next step in the investigation. That goes against what the scientific community recommends and what most labs or other police departments would do. Other police departments and labs would prioritize blood DNA profiles that are found at the scene. They would not prioritize trace transfer DNA unless there was linking evidence. There is no other linking evidence. That's just a small amount of nothing that leads nowhere. And so it was somebody's discretion that is away from their policies and procedures where that decision had been made. And that had been made prior to ever investigating those. So when Bill Thompson said that those weren't eligible, I don't believe there's any criteria. And I know people are getting stuck in the definition of the word eligible. Eligible implies there's some sort of criteria to go with it. I don't believe in this case. I believe in this case that just means law enforcement didn't pursue it. It's not eligible to the investigation because they're not going that direction. And I know there's people out there that may disagree with me, but just like in medical terms, just like in the law, sometimes formal words like that can have a completely different context than how we would normally use it in our everyday speaking, in our everyday English, or your everyday language, or whatever you speak. In this context, that word eligible within their work environment does not mean how we use it everyday speech, everyday language, in my opinion. So, all right, next one. Alert that profile descriptors cannot be applied to activity level issues. Oh, that's interesting. All right, what do they say about that? DNA profiles may be described as major, minor, component 1, or with differential extraction suffixes for analytical reasons. However, these descriptors should not be interpreted in the context of a decision regarding the nature of the material or mechanisms, actions, or timing that led to the deposition of the DNA. Boom. Let me read that again. So this reason for a limit or a caveat, you receive an alert that a profile descriptors cannot be applied to activity level issues. That would be the sheath. That would be the DNA that was found in the sheath. We don't know when or how that was deposited. Whereas activity level issues of how or when actually spilt blood DNA ended up on key areas, the handrail, somebody might be running down the stairs to exit, or somebody could have been wearing gloves while they were wielding whatever weapon was used, and they're taking it off and they're running as they're leaving the house. Those aren't conspiracy theories. Those are things that happen when people commit crimes. They do take their gloves off at some point, and a lot of times they wear gloves to protect their hands from bodily fluids like that. So that glove is actually, to me, I know people are like, well, that was found outside the house. That one's not as important as the one on the handrail. No, I think that a glove is actually a linking piece of evidence. My light went out. And so the activity levels with those, there's more of a scientific standard. There are scientific ways to evaluate that blood was most likely spilt during that event. Whereas with the trace minute amounts on the sheath, I'm sure somebody got the alert that, hey, you might not be able to tell how and when that was deposited. Because there are experts out there that know. Bika Barlow pointed out that there was an expert, I think it even was a state, or was it the defense expert, that they were, they stuck to. Lab analysts can only testify to and are limited to identity. They didn't step outside of their role as to identify. And so you can't, I just lost what I was saying. Anyway, so yeah, you can't attribute activity level to the sheath or the DNA on the sheath. And so, let me read this again. DNA profiles may be described as major, minor, component 1 with differential extraction suffixes for analytical reasons. However, these descriptors should not be interpreted in the context of a decision regarding the nature of the material or mechanisms, actions, timing that led to the deposition of the DNA. Bingo! They were saying that it's single source, and the state was placing weight on the fact that this is single source. And this says right here, these descriptors, a descriptor, single source, should not be interpreted in the context of a decision regarding the nature of the material, the mechanisms, actions, the timing that led to the deposition of the DNA. Just because it's single source, you still don't know how and when it got there. And then that shouldn't have any weight on it. Okay. So the next one is convey the limitations of an exclusion. This is another thing because, did you guys recently watch Cara Willis's recent video? Danger Zone, welcome back. It's so good to see you. Here we go. Larissa Harris says, I heard Vinny on Court TV say, well, if the defense really wants to know whose blood was on the railing, that they should test it. Bothered me taking accountability off law enforcement. Yeah. I felt the exact same way about that. Welcome back, Danger Zone. Yvonne Poole says, the defense has much less money and resources available for them. They could test it, but that was something the state should have done. She doesn't have to prove him innocent. They need to prove guilt. Yeah. Larissa says, yes, I agree, Yvonne. Thought it was crazy when he said that downplaying law enforcement not doing it their job. Yeah. Well, I've been learning, especially through this case, that the mainstream media, that type of media, there's good media out there. A lot of it you can find here on YouTube. But that particular type, I don't know, I guess it's called legacy media. They're an extension or arm of the state, pretty much related to the police department. So the system is set up for them to respond like that. And they want to, so that police will keep giving them information that they can disseminate to get viewers. So they're going to be very amenable to the law enforcement and say basically what they want them to say. So they're going to say anything that makes the police look the best. Yeah. So Bika Barlow, was it the inconclusive results where this whole thing about the fingernail clippings, it was the likelihood ratio. It was comparing two hypotheses about what was happening with Maddie's left fingernail clippings. The two questions were, is it Maddie, Kaylee, and one unknown person, or is it Maddie and two unknown persons? And so what they did was, even at the grand jury, they were saying that this is exculpatory to Brian, but in my opinion, the state fully took advantage of the jury not quite understanding how likelihood ratios work, how DNA works, and just saying, well, it was inconclusive, so he could have been or couldn't have been. That's not how it works. It's not a question of identity. It's a question of, were these two unknowns, or was it Kaylee and an unknown? And I'm not sure how they do the statistical map. I think I can pull it up for you. I think I have it. Yeah. So let me scroll in here. Inconclusive data. Yeah, here we go. So here. Likelihood comparison of hypotheses is not a statement of identity or probability of identity. It simply asks the question, given the data, which hypotheses tested is more likely for item Q13.1? Both hypotheses tested for each individual assumed that Maddie Mogen's DNA was present. They assumed it, which is okay, because I guess the sheath was near Maddie, so they're thinking that her DNA was on it, was present on it. So when the lab generated the likelihood ratio laid out above, the hypotheses were Maddie, Kaylee, one unknown related person, versus Maddie, and 2 unrelated persons. This comparison was done for all the individuals listed in report number 7 and for Mr. Koberger in report number 6. So they just asked questions about the likelihood of Koberger, not that it was. At the ISP lab, any number greater than 100 is considered conclusive, resulting in indicating inclusion. Any number less than 0.01 is considered conclusive, resulting indicating an exclusion. So anything above 100, anything below 0.1 are conclusive results. They're like on either side of the spectrum. And what's conclusive about them is one of them is included, the other one is excluded. Okay, and then anything that falls in between the 0.1 and the 100, there's all this space here. The lab cannot draw any conclusions with that data that is reported, and it's reported as inconclusive. And so juries typically think that means, well, you can't rule them in or out. So that means they're probably in. They're probably, they're probably a match. Since the police can't know whether they're a match or not, that means they're probably a match. Anyway, no, that's not what it means. No, it just means they can't answer the question. And then, of course, they did probability here. This isn't actual. I don't think this is actual DNA results. I think this is still statistical. Well, they could have some of their DNA in there, but still, this is not identity. And so it says lab resort number 7 at 3. All of these individuals sit in the same shoes as Mr. Koberger. Oh, does this mean these are people? Namely, the likelihood ratio is exclusionary, but falls within the range of inclusive. All right, and in Cara Willis's, I think it's not her live, but the video right a few hours before her live, she did an excellent job explaining this. I highly recommend watching that. I will put the link in the description box. But she was, I think it was Vinny. Believe it was a Vinny news clip. He was like talking, and he did that same thing you were just talking about, Larissa, where he just downplayed. He had an expert on. And she was answering, actually, she gave very good answers, very clear answers that actually helped me understand this more. He completely downplayed it, like ignored what she had to say, and just kind of was just like, we don't know whose DNA was really under there. Like, no, that's not what this exercise is about. And she did an excellent job saying that again, going back to the standards and standards of practice and the operating procedures and how labs, they all have different standards of or spectrums of what they will consider inclusive or exclusive, and what they, where they put the analytical threshold or the stochastic level line. And then she was saying in this particular case, maybe one lab has stricter standards than the other, or maybe one was just very loose and it didn't really fall on the industry standards. So it could have been an exclusionary the entire time, even if the initial lab reported it as inclusive. However, even though Brian Koberger was excluded, and that exclusion was on the range of inconclusive, it still read exclusionary. And I know that probably doesn't make sense because it's probably a graph. And you know how like sometimes in a graph, you can have ranges where it still falls somewhere, but even though it's falling somewhere, it's still not related or it's excluded. I don't know how to explain that. You're going to have to watch Cara Willis's video. It was excellent. Excellent. And I even I shared it in a post. So it is under my post too. But I will still put it in the description. She did an excellent job. And it was her birthday yesterday. So she uploaded that on her birthday, and she had a very good live for her birthday too. It was long. It was good. I was there for most of it. Okay, so. Okay. It also says, of interest is that when the likelihood ratio was calculated for, I don't know if these could be names. Thus, Mr. Koberger's inconclusive likelihood ratio is similar to almost every other person for whom the likelihood ratio was generated. And focusing on his inconclusive likelihood ratio would mislead the jury. It implies that the likelihood ratio means that Mr. Koberger's DNA might be present in the sample, which that's not what it was asking. All right. And it also says, more importantly, Mr. Koberger has disclosed that for further independent laboratory testing, he is eliminated as a contributor to item 13.1. When Mr. Koberger sought to overturn the grand jury indictment, he argued that Miller's testimony was inadmissible and misleading. The state argued that the testimony was presented to the grand jury as exculpatory in an effort to elicit favorable evidence to Mr. Koberger. Yeah, right. The independent lab testing conducted by the defense team related to item 13.1 is indeed exculpatory. Mr. Koberger is excluded, and the state should be precluded from misleading a jury in that way. So I wanted to explain that a little bit in regard to the case, because then it says to convey the limitations of an exclusion, which I do believe is that situation, well, as closely to this reason for caveat or limitation. That's the closest we're going to get in the case that we're referencing. And to respond to that, so how this Miller, was her name Miller? Yes, Jade Miller. So the way Jade Miller responded to this was inappropriate. And NIST is going to tell us, the National Institute for Standards and Technology is going to tell us what the recommended way, to avoid errors like we have in this Brian Koberger case. This is how she should have responded. Results suggesting that a particular person of interest should be excluded from a possible contributor to a DNA sample must be interpreted within the context of the case. There could have been an error in the process, or the absence of DNA of this person from the material may need to be assessed in context of the case by considering factors such as persistence of recovery of DNA. This is a different spot. This was DNA with the left hand of Maddie's fingernail clippings. That's not the sheath. And so the material they were looking at is not the sheath, it's something else. So to say that since a minute piece of evidence was found over here, could it have been found over here? Okay, that could be a little legitimate question, but that's still not a question of identity. And so for Jade Miller to present to the jury in any way like that was a question would be absolutely misleading to a jury. Absolutely. Yovan says, They don't even want to hear that the sheath is a movable object with a tiny bit of transferred DNA on it, and the sheath never killed anyone. Prove the homicide weapon came from that sheath too, right? Larissa says, I know. Some mainstream media has saw the light with Karen Reed, but people and media hear knife sheath and don't care about the investigation anymore. When I looked closer at the case, I saw issues. See. All right. So the next one. Here's another limitation. Convey that DNA results cannot be interpreted as the analyst providing an opinion regarding who the source of DNA is. Convey that DNA results cannot be interpreted as the analyst providing an opinion regarding who the source of the DNA is. All right. This report and evaluation do not directly answer who the source of the DNA is. Rather, the reported results may help answer questions about the source by providing an evaluation of the results in light of the propositions, i.e., the person of interest is the source of the DNA versus an unknown individual, the source of the DNA. Yeah, so they're asking a question here. Is it this person? Is it more likely to be this person or that person? Not that it actually is. This assessment of the DNA results should be integrated with other case information and evidence by the end user, which is considered to be part of the DNA analyst task. DNA evidence evaluations. Oh, hold on. This, no wonder I was having trouble understanding. This question bled further into the next page. So let me start over with this reason because it goes all the way down here. Convey the DNA results cannot be interpreted as the analyst providing the opinion regarding who the source of the DNA is. Likelihood ratios cannot speak to the likelihood of a proposition, only to the probability that the results given a pair of propositions. Right, so the likelihood ratio is asking questions or comparing two hypotheses. It's not identifying. And so the way that you would respond to this type of limitation, so convey that the DNA results cannot be interpreted as the analyst providing the opinion regarding the source of the DNA is likelihood ratios cannot speak to. Right, just like we were just talking about. Jade Miller, she's speaking to a limitation. A limitation of forensic science is that even though the state was said to the grand jury that this is exculpatory, they were still misleading the jury and talking about something, confusing the issue on something about forensic science. And this is how you would report that, what Jade Miller did not do. This report and evaluation do not directly answer who, this is how she should have answered, but apparently they failed to do that, and that's why Bika wants it out. This report and evaluation do not directly answer who the source of the DNA is. Rather, the reported results may help answer questions about the source by providing an evaluation of the results in light of the propositions. For example, the person of interest is the source of the DNA versus an unknown individual is the source of the DNA. This assessment of the DNA results should be integrated with other case information and evidence by the end user, which is not considered to be a part of the DNA analyst's task. DNA evidence evaluation should not be used as the sole evidence to completely rule out any one view, for example, proposition. The biological results must be considered within the context of all the information and evidence available in the case. This decision is outside the role of the DNA analyst. A likelihood ratio indicates if and to what extent the DNA analysis results support one proposition over the other. It is not possible on the basis alone to determine which the most probable proposition. To assign the probability of a proposition, the DNA analysis results should be combined with other information in the case. This is not considered to be the role of the DNA analyst. So that wasn't Jade Miller's role to infer or even say anything that could possibly mislead the jury. And even though whatever her answer was obviously misled the jury, Bika Barlow caught it. So, and I think one of the things the expert on Vinny's show was saying that, like, wherever Brian was on the scale, because even I think Bika says it here too. Yeah, of interest is that when a likelihood ratio was calculated for redacted, thus Mr. Koberger's inconclusive likelihood result is similar to almost every other person, like me or you. We would have had similar results, but just not. We just wouldn't have been in the proper question of the likelihood ratio. Okay. So where are we now? The next one is convey that DNA statistics cannot imply uniqueness within a population. Based on DNA results only, even when presented with a reference to a local or world population, scientists cannot opine whether the person of interest is the source of the DNA or not. What does that sound like? To me, that keeps sounding like the octillion statistic. The octillion statistic was based on a world where nobody's related, and there's octillion amount of people. Octillion people. So, so when an expert is communicating these, the expert should not convey. No, the limitation is DNA statistics cannot imply uniqueness within a population. Wait, no, I said that wrong. Convey that DNA statistics cannot imply uniqueness within a population. And so the proper way to report that is based on DNA results only. Even when presented with a reference to a local or world population, scientists cannot opine whether a person of interest is the source of the DNA or not. I'm not sure how to say that, but immediately I'm like, that has to be talking about the octillion statistic, because that one is based on a world where nobody's related and there's octillion people. Okay, next one. Alert on the difference between source level and activity level issues. This report does not provide any information on the mechanisms or actions that led to the deposition or absence of the recovered biological material. It only provides information that may help inform its origin. For example, who is the source of the DNA? Exactly. And this is the entire state's case right here. And the entire scientific community is against them. And we are in the NIST report that took 4 years to make. And it's the scientific community census that the state's theory of the case is not founded in science. There is no way, there is no technology, there are no standards or practice. Actually, the standards of practice say that they can't do this, where their experts should be saying, this report does not provide any information on the mechanisms or actions that led to the deposition or absence of recovered biological material. It only provides information that may help inform its origin. For instance, who is the source of the DNA? Which means Riley Nolan, if she goes in there and says, I believe that this was done via direct transfer, she's going in opposition of the general consensus of the scientific community. Like, usually that's not okay in a court of law. Incredible, just incredible. All right, so next one. Delineating the meaning of a verbal qualifier. Okay, so the way I guess an expert should respond or communicate this is, the likelihood ratio is a numerical value. Words can be assigned to brackets of numerical values and used to describe the extent of the support that the results provided for a proposition over another. Several verbal equivalence tables have been published, and they are, above all, a convention. Delineate the meaning of a verbal qualifier. So the likelihood ratio is a numerical value. Words can be assigned to brackets of the numerical values and used to describe the extent of the support that results provide a proposition. Right. That doesn't say anything about identity in there, because the likelihood ratio is not about identity. All right, next. Convey that a new evaluation cannot be performed on the witness stand. Okay, the way that someone should respond or communicate that. Testimony cannot be given regarding evaluations that were not provided in the report or documented in the case file. If the issue changes, for example, the source of the DNA is no longer contested, a relative of the person of interest needs to be considered. Or the issue pertains to how or when the DNA was deposited. A new evaluation will be needed in advance of the trial. What? Wait. So a caveat or a limitation would be to convey that a new evaluation cannot be performed on the witness stand. Uh-oh. Is that exactly what Payne did? Well, Payne's not, well, I don't know. He's not quite an expert, but he said another evaluation, nobody could put it in anything else than CODIS. And then why didn't any expert along the way convey this? Why did the experts along the way why do the experts along the way convey that a new evaluation cannot be performed? I didn't hear any of them communicate this in any report. Ann Taylor didn't see it in any report or email or anything. Any verbal or written communications, this was not found. And an expert should have responded this way. Testimony cannot be given regarding evaluations that were not provided in the report or documented in the case file. If the issue changes, for example, the source of the DNA is no longer contested, let's just say, let me start over. Testimony cannot be given regarding evaluations that were not provided in the report or documented in the case file. If the issue changes, for example, the issue pertains to how or when the DNA was deposited, a new evaluation will be needed in advance of trial. So a testimony cannot be given regarding evaluations that were not provided in the report or documented in the case file. If the issue changes, a new evaluation will need to be done in advance. Yeah, so in the case file, it's not going to be reported how or when the DNA was deposited. So how can testimony be given regarding those evaluations of how and when? Because of the limitations of the technology for that. So an expert should not convey that a new evaluation cannot be performed on the witness stand. And the testimony should not be given pertaining to something that is absent. And it's not going to be written in a report how or when the DNA was deposited, because we don't have technology or standards to communicate that. So an expert should not be on the stand communicating that. All right. There we go. Next one. Introduction and scope. This is for pre-trial preparation and testimony. Offering clear and accurate testimony is an essential part of the DNA expert's role in the criminal justice system. Because the fact finder determines how much weight to give the biological evidence results in deciding the case, testimony should enable the fact finder to suitably use the DNA results and experts' opinion in their decision making. To this end, experts must testify within the bounds of the scientific and technical expertise. The how and the when are outside the bounds of lab analysts' scientific and technical expertise. The Expert Working Group, EWG, explored research on the effective communication, the limits of human cognition, and how lay people understand different forms of testimony. We also explored the bounds of the scientific expertise and ways that DNA analysts might express DNA comparison results in a way that could understate the limits of the science or amount to giving an opinion on topics that are in the remit of the fact finders. We consider these search findings. This is important. I'm going to blow it up. Larissa says, defense needed someone like Bika. Her background was a must for this trial. Absolutely. I said before, like Bika was made for this trial. Bika was made for this time in history. It's just absolutely incredible to have someone like Bika right now, like combating these issues. These issues are huge. Like these issues are like harming humanity. They're so bad. All right. We considered these research findings within the context of the United States legal system, and they are presented in this chapter along with examples concerning appropriate pre-trial and testimony communications regarding DNA results, the expert's role of communicating evaluations of DNA results given at least two mutually exclusive propositions as formulated considering case information, common testimony pitfalls and approaches to help prevalent misstatements that could impact judicial outcomes, expressing limitations and caveats associated with DNA analysis. And we just read all of the limitations and caveats that this report lists. This is what we were just reading before I got to this paragraph here. Yeah, where was I? I think somebody in the comments was telling me that none of this is real. And they were saying that what Riley and Nolan was saying was true, and that they gave reasons. But no, right here, this is the scientific community. This is what the experts do when they're writing best practices for the United States legal system. I don't know how to express what document we're actually looking at here. This document is the scientific community. This is the consensus. This is what they use for all of those, like the Daubert scale or the Fry scale, or was it Rule 702 in Idaho? To consider an expert is that what is the general consensus of the scientific community, and that is one of the weights. And then whatever the expert is going to show, or whatever technology they're going to share, they're going to balance it with what is generally accepted. And this is that body, that weight that you would use to balance out, whatever the expert is going to say. Now, Idaho's Rule 702 is a little bit more lax than that, because I think the judge gets to decide who's an expert and who isn't. And I don't think it's as stringent as the Daubert or the Fry measure. But this work right here plays a critical role in how an expert would approach providing their testimony in court. As somebody has a base or a foundation or has some guidelines on what to do when they're in that position. This is it right here. This is brand new though. So this isn't something that has been out for a few years or something that, the expert would have known. Well, they should have known because it was there, but now it's just all kind of organized and put into one place. That this is the latest and greatest out there. So anything that Riley Nolan was saying, it's not in line with this, then it's most likely incorrect. And the way that she went about it is outside her bounds. She is limited to identity, and she was speaking on something that's not identity. And that is one of the most important things when it comes to operating procedures and the systems approach for identification. The system approach is much different, but again, than just saying, okay, I'm going to look at this material and this number and I'm going to say it was direct. No, it's a whole life cycle of things that go into interpretation, and Riley Nolan skipped over the majority of it. And so did that Jane Miller, apparently. Anyway, this chapter's topics closely relate to those in Chapter 4, quantitative and qualitative ways to express DNA results, and Chapter 5, reporting, for a discussion on testimony as it relates to serological screening results. Oh, I want to go over that sometime because serological screening tests were not done on the inside of the brass snap. Apparently, they just went right to STR. I don't know why. There might be a perfectly good explanation for that. Maybe it was metal. I don't know, but they did serological testing on the sheath, and it did test presumptive for blood, and Brian's was excluded from that blood. So, but again, the back of the sheath, of course, is a different material. So I don't know if that had anything to do with it, or did I have some in my eye? Hold on. And you know what? While I'm digging in my eye on Cara, I'm going to put on my light again because it's easier to see. So give me just a sec. Okay. Can you guys see better too? I really like this blue light. Well, actually, it's blue and pink with blue stars, but it's a lot brighter in person than it shows up on camera. Okay. Legal rules and practices concerning testimony vary between jurisdictions. Some experts may be bound by specific licensing or oversight body rules regarding testimony. And believe it or not, licensing and oversight body rules are a part of DNA interpretation because it's part of the systems approach. And this is the approach that the scientific community is going in now. And a lot of this report is about the limitations. And limitations are also a part of the systems approach. And they also mitigate risk when the limitations are known. So this chapter provides only general guidance and is specific to providing testimony on DNA comparison results, i.e. subsource level DNA results and hierarchy propositions, the importance of case assessment and information. It is important to consult with appropriate oversight bodies, criminal justice partners, and forensic service providers, counsel regarding applicable governing laws for specific forensic service jurisdiction. The intent of the guidance provided to assist experts in identifying and advocating for communications to further the goal of the appropriate use of science to achieve fair, just, and accurate resolutions. To achieve this goal, it is imperative that forensic service providers, management support, scientific or technical experts, by providing dedicated time for analysts to develop oral presentation skills. Oh, that just gave me a thought because it does say here that a lot of this is guidance. However, if I were an expert, I would definitely want to be aware of the scientific community and best practices. It might not be law, but it certainly says a lot about your work ethic. It also says a lot about your organization. If you are in direct opposition of the scientific community and you're trying to convict someone, you know, I don't know, that just doesn't, because I know that people out there be like, well, it's not law, so Riley Nolan can do that. No, it's a little bit more involved than that. So, general considerations for expert testimony. Rule 702 of the federal rules provides that a witness who is qualified as an expert by knowledge, skill, experience, training, or education may testify in the form of an opinion or otherwise. Most state-level rules regarding expert evidence employ the same or similar language. Testimony by a DNA expert should assist the fact finder's understanding and evaluation of the meaning and appropriate value to be given to the DNA results. Yeah, and that also reminds me, what's that quote? What was it? Great knowledge comes great responsibility. All right. Snoopy Red says, I think after being in for so long, the only thing they keep is hope, but they have to learn not to show emotions for all to see. It's a survival in the penitentiary mechanism. Sad it takes so long. Yeah, sad, very well said, Snoopy Red. Larissa says, AT doing a great job, but she's not expert at DNA, and she will be able to make sure these scientists on the up and up. Absolutely. Absolutely. Well said, too. You guys say a lot of great things in here. Thank you. Right. What is it? With great knowledge comes great responsibility. So these DNA experts, they have a responsibility to try to explain to the jury, honestly and accurately what's going on here. I don't know where their sense of morals are. Is it with the police department to get a match, or is it with the jury? It should be with the jury so that they can understand what's going on. And apparently that's not what's going on here. And, that's fair. That's fair. The basic tenets of expert testimony include qualifications, reliability, relevance, impartiality, clarity, and consistency. Appropriate testimony should be reflective of and supported by written reports and case records. 2, accurately convey the results and examinations, observations, interpretations, conclusions, and opinions, as well as provide additional information in response to questioning from criminal justice partners or the court. 3, present information in a clear, complete, and impartial manner. Yeah, I was just saying that. There's a responsibility there. 4, explain the meaning of the results within the context of the task-relevant information that informed the analysis. 5, present the limitations of biological results and DNA comparisons relevant to the methods used to produce the opinion being testified to. 6, whenever possible, use language that is easy for lay people to understand. Only those personnel qualified and authorized to present an opinion should do so. See Section 6.7, establishing a DNA analyst as an expert during testimony. International organizations for standardization, International Electrotechnical Commission, specifies that when opinions and interpretations are expressed, we shall ensure that only personnel authorized for the expression of opinions and interpretations release the respective statement. Although ISO standards may only formally apply to experts, the ISO accredited forensic service providers, the EWG recommends that all experts follow this guidance or comply with the principal goals the standards are intended to address. Okay. The expert working group. Is that all the experts in forensic science? Is that their consortium, their consensus, their, where they discuss things and they iron things like this out. So this would be who, if you're an expert, you would turn to. and they're recommending experts follow this guidance. The adversarial nature of the United States criminal justice system is not always aligned with the scientific community's goals. Oh, yeah, we kind of figured that one out when it comes to testifying. Scientists are tasked with presenting the most complete and accurate information relating to any scientific opinion being offered. Attorneys, however, operate under their own set of legal and ethical obligations and interests, which are distinct and sometimes opposed to those of science. Moreover, experts cannot control the ultimate perceptions of the fact finders may have about the offered testimony. As expressed by Stoney, the courtroom is not a scientific arena. He posits that it's important that we use scientific criteria for evidence, but the law has built a system that is based on personal, subjective human judgment. So I can testify and the jury can decide they didn't like the way I looked or responded to questions and they dismissed me entirely. While frustrating, the control that expert witnesses have is undeniably limited. Despite this, experts should always attempt to provide clear and accurate information concerning complex DNA and statistical concepts. In response to the questions posed, expert opinions communicated during testimony should be supported thorough written reports and completed records of any analyses conducted. Whenever legally possible and permissible, analysts should participate in pre-trial meetings or consultations with all parties to mitigate potential misunderstandings of their findings. Here's a call-out box. The adversarial process impacts DNA analysis and interpretation of DNA results. When experts are called to assist in legal matters, the environment of the legal system will always, to some degree, influence testimony. In countries that operate under an adversarial legal system, the prosecuting party and defendant face off during the pretrial and court proceedings. Each side presents evidence to support their theory of the case. To do this, each side will frame the evidence in a different way and may supplement it with narrative that they believe will convince the fact finder. The party requesting the services of the DNA analyst may color the analyst's approach or testimony in a phenomenon called adversarial allegiance. Yep. I never heard it put that way. That's exactly what it is. The party requesting the services of the DNA analyst may color the analyst's approach or testimony in a phenomenon called adversarial allegiance. Isn't that amazing? That the scientific community is pointing out a psychological response or relationship that happens within the legal system. It's a psychological phenomenon, right? So, wow, this is a very thorough report. I don't know if I've ever read anything so comprehensive. And so that's just a really well-written statement. I'll read it one more time and move on. The party requesting the services of the DNA analyst may color the analyst's approach or testimony in a phenomenon called the adversarial alliance. Let me know in chat or in the comments if you've ever heard that phrase, adversarial reliance, before, or adversarial alliance. I haven't. Consider a situation where the prosecution has asked for a DNA expert to write a report and testify in an essay case. The prosecution is asking the DNA expert to weigh in on whether the DNA from the sexual assault kit came from the defendant or not. The information they provide to the analyst may be framing their request, may influence the analyst. Furthermore, the fact finder may interpret the expert's testimony considering the arguments made by the side that called them. So even balanced or neutral comments might be interpreted in a biased manner. This effect might be similar when the defense calls a DNA expert. Yeah, so, yeah. And I think that this, what pops into my head are people that say, well, I don't know why the defense is asking for all this DNA to be suppressed. Like, doesn't that make them look guilty? No, it absolutely does not. What it does is that no, it's because it's because of this adversarial alliance. It's exactly that. And so what the defense needs to do is to comb through the case and find those specific points of where that could be occurring the most, because that can be very detrimental, that can be very prejudiced. So you want to try to keep those things from coming into trial as best as you can, because it's another psychological phenomenon that the jury usually weighs the prosecution's experts more than the defense experts. And so when the defense is asking for things to be excluded or not admissible, that is not a direct line explanation or showing of the hand that anybody is guilty. It doesn't say that that information or that fact is a bad fact. I mean, it could be, but a lot of this is a psychological phenomenon, and it's working within this adversarial system. So even though there might be outward appearances that maybe somebody could think, well, if they just let this DNA stuff in because they shouldn't need to worry about it, or like, what do they have to worry about? I think it's a little bit more complicated than that, especially when it comes to the adversarial nature and these adversarial alliances. And I even think that even though there might be a relationship there between the experts and the prosecutors, there might also be an underlying subconscious one between the jury and the prosecutors as well. They could play a role in that adversarial alliance and they might not even realize it. Not all the time, but so like the decisions that the defense makes it's not always as clear cut. And these subconscious patterns or subconscious relationships that groups of people can have, that can be powerful. And so no matter what the case circumstances are, or whatever the facts are, I don't think it's an accurate representation of the psychological circles that happen that are majority invisible. Like, it's going to take a little bit of reflection to actually kind of look into what those factors could be and how they play a role in the courtroom. And even the actors in the courtroom, the defense, the prosecution, the judge, they might not even be cognizant of the types of subconscious things that goes on with them. It really only becomes apparent when there's a study of it, and then we can read the fun study, in one of these scholarly journals, and then we can reflect back and say, oh yeah, I have noticed that throughout my life experience, that oh yeah, that can happen in the courtroom, or oh yeah, I remember examples of when there's these unspoken alliances that are just not they're not, that people aren't aware of them or cognizant of them while they're happening, but so yeah, that's what that reminded me of. Yeah, so that happened. All right, I think I'm going to come back and see what you guys are saying here. Here we go. Larissa Harris says, defense wants to suppress to make sure the prosecutors don't spin the results possibly. I 100% agree, because I think what Bika Barlow has been pointing out is that at least 2 of the defense experts have been speaking outside of their scope. I mean, I guess it's their human right to offer an opinion, but they're not making it clear to the jury that that is out, especially when it comes to the how and the when, and even on the likelihood ratios. These experts are they telling the jury the likelihood ratio, when we give you this statistic, it's not about identity? I would argue that the likelihood ratio shouldn't be allowed in the courtroom because of how confusing it is. And even if the expert does explain to the jury that the likelihood ratio DNA statistic is not a question of identity, I still don't even know if that's going to help. So, yeah. All right, I dropped. But yeah, I think you're so right, Larissa. Larissa, I don't know if I've seen you here before, but like everything you're saying, I'm like, yeah, that's exactly how I feel. That's so funny. I feel like we would be friends in like real life. I have something really exciting to show you guys, but like maybe I'll wait for next time to share it. Now it's late, no wonder. Well, I hope that was all kind of helpful and interesting. I find it to be absolutely fascinating, this whole thing. And, even though the other article that I consider my favorite, I think this one just stepped up, even though they're written by NIST. I must really like NIST. So I'm going to wait till next time to share some really big news, some really exciting news I think you're all going to love. And I want to thank everybody here who came, was in live chat, and everybody on the replay crew. I had a lot of fun. And I hope you all have a good rest of your weekend. And I will see you on the live soon. Take care. Bye.